Hi, today we are looking at integration by substitution. Sometimes this is referred to as U substitution. So if we say U equals a function g of x, then if we have integral of f of g of x times the derivative of g of x d of x, then we can say integral of f at u derivative at u. Now, when we take our integral of this would be our function f at u plus c, which would be f at g of x plus c. So for example, evaluate, we've got the integral of x squared minus 5 to the power of 8 times 2x d of x. So what we can see here is essentially we have a function that's to an exponent. So this inner function would essentially be our g of x. Now we can see our derivative of that right here. So this is our g prime of x. So what we're going to do is we're going to say let u equal our function g of x, which is x squared minus 5. Meanwhile, if we take the derivative of this, we can say du dx is equal to 2x. Rearranging that, we get du equals 2x dx. What you'll notice is this part here matches what we have here, and what we have here matches here. So we're going to substitute those in. So we now have the integral of, we said u was x squared minus 5, so integral of u to the power of 8, and then 2x d of x we said was equal to du. Now if we look at our integral of u to the power of 8, that'd be 1 over 9 u to the power of 9 plus c. And then we'll substitute this back in, so we have 1 over 9 times x squared minus 5 to the power of 9 plus c. Next example, we have the integral of x squared times x cubed plus 1 to the power of 8. So once again, we'll take this as our g of x, and we'll say u is equal to x cubed plus 1. Now du dx would then be 3x squared. Now, if we look at that, that doesn't really match up here. We don't have a 3x squared here. We just have an x squared and a d of x. So we need to get it like that here. So I would probably multiply both sides by dx. So we've got du is equal to 3x squared dx, and then divide both sides by 3. So du over 3 is equal to x squared dx. So once again, we'll do some substitution because our x cubed minus 3 here will go in for this x cubed minus, or sorry, x cubed plus 1 will go in for this x cubed plus 1. Meanwhile, our du over 3 will go in for our x squared d of x. So this will be our integral of u to the power of 8 times 1 over 3 du. We can move that 1/3 to the front, so we've got 1/3 times integral of u to the 8 du, which would be 1/3 times 1/9 u to the 9 plus c. So that gives us 1/27 times x cubed plus 1 to the power of 9 plus c. Okay, so we'll look at some more integrals from the table of integration. Now, I just realized I have a typo in this first one. This isn't a squared equals x squared, that's a squared minus x squared. So if we have integral of dx over square root of a squared minus x squared equals sine -1 of x over a plus c, and our integral of d of x over ax squared plus x squared equals 1 over a times arctan of x over a plus c. So we'll look at a couple examples. So for example, evaluate. We have integral of 1 over square root of 9 minus x squared d of x. So we want to see which one this matches up with. So this is one that is minus. We'll see that it's our a squared here that creates our a that goes here. So in this case, that's 9. Square root of that would be 3. So therefore, this would equal sine -1 of x over 3 plus c. Now this one here is similar, although once again this should be a squared, but we can't take the square root of that, so when we take and get an integer, so we'll just leave it as a square root when we come up with our answer. So if this one, it matches our tan one, which our tan one has 1 over our a value, so we've got 1 over square root of 5, and then arctan of x over our a value plus c.